Hello and welcome to the tool paper presentation of FAXE. My name is Tobias Schwarz and I'm presenting you a common notation for embedded annotations, which represent software features and tool support to extract feature locations from embedded annotation. Software features are defined as logical unit of behavior that is specified by a set of functional and quality requirements. They are central in the agile processes and serve to keep an understanding and overview of the functionality of software projects. They are also used, for example, in large-scale systems and variant configuration-rich systems such as the Linux operating system or the Marlin 3D printer or Clever web tools. To work with software features, their location needs to be known. Feature location is an important and frequent task in software development, and when not recorded, feature location is difficult because features are abstract entities, so they are scattered around the source code, they are user-facing and cross-cutting and tangled by nature. Therefore, feature locations need to be documented, and we propose to do this while software development and evolution, because this is the point in time when feature knowledge is available in the developer's head and over all levels of software assets, and at the same time to document it in the software assets themselves. With this information can retain during reuse and maintenance operations, and by supporting a lightweight process and tooling, they are easy to document. All of that can be done with the notation of embedded annotations. Before going into the details of embedded annotation, let's have a look on some use cases. For example, we can get the feature location to browse them. Can have, with the help of feature metrics like scattering degree or tangling degree, a good way to have a non-technical perspective on the software project. We can see feature relations between features and the folder and file structure. And with the feature history, we can keep track over the software evolution. The motivation for this work is to improve current use cases and enable new application scenarios. For this, we need a unified syntax for embedded annotation, because only when this is standardized, developers know what they expect from the tools, so also to work over project boundaries in the same way, and tool creators know how the developers are going to use them. This is something we want to support with a lightweight tool to replace full textual search, to be able to browse through your features, and it shall come with a minimum set of dependencies. In our paper, we discussed an extended use case where we proposed feature-oriented isolated development. When a developer is working on two or more features simultaneously, in the end he wants to commit his changes to the version control server, which is done classically on a file and folder level, and the developer can provide a commit message which describes both of his independent changes. This coarse-grained commit is not what we want to have. We want to have a change in the perspective to commit features instead of file and folders. Developers already try to commit features themselves, but this is complicated and time intense. So what we want to do is committing features instead of files and folders, and with the help of the feature locations, which is provided by the embedded annotations, this is now possible. To work with embedded annotations, we need a unified specification. Literature is proposing different approaches for documenting features in source code, but they differ from each other even when these specifications are derived from each other. The four listed ones are the foundation for our embedded annotation specification, where we follow for this specification the design properties to be reliable so that it is easy to applicable and flexible to use, intuitive to document your features with it, and when you see them to easily understand which are the features in there, and they shall be robust against changes and to be able to evolve with the source code itself. And over all levels of software assets, they shall be concise. The running example where I'm going to explain the embedded annotations is the Bitcoin wallet project, where we have from a previous work an annotated dataset of its source code. You can find the source code beside others in the research group's Bitbucket repository. When you want to incorporate features with your project, you have to add them to the feature model. The feature model is a specialized file and put in the root folder of a project. It is a fully textual representation, so it does not require any further tooling or configuration that developers can modify it. It has a one-tab indentation per level down in the feature model. Feature names in the feature model can be non-unique, which means at different parts of the model the same feature name can appear. To apply features to your project now on the highest level, we can map features to folders. This is done with specialized file put inside the to be annotated folder. This causes a mapping of the whole folder, including of its content and subfolder, to the features specified in this file. With this technique, you can map source code files, but also non-source code files like binary files or generated files, and is so with that very flexible. As mentioned before, feature names can be non-unique, which is, for example, here the case with codecs, which appears twice in the feature model. If this is the case, the feature name is prefixed with its parent name until the expression is unique. This technique is called least partially qualified names and can be used over all hierarchies of the project. From the folder level, we're going to the file level, which is as well realized in a specialized file, which is put in the same folder as the to be annotated files. This file consists on pairs of file names, which can be a single file or multiple file names in a row, and the to be mapped feature, which can be one feature name or a list of it. This is our last specialized file, and the benefit of these mapping files is that even without touching the source code, already a good mapping of features to your software project can be done. On the level of text annotations, we can annotate all kinds of text files, like source code files, configuration files, or a README document. And in here, we can annotate fragments of the text, starting with an ampersand and begin keyword, followed by the feature name, and ending with ampersand end, and a repetition of the feature name. A specialized form of it is ampersand line, which annotates only the line it appears in. Using this in source code file is programming language independent, as we're using the command characters of the host language not to influence the program flow. We want to have an as flexible as possible approach. For this, features can be nested between each other, either completely nested or partially overlapping, like on the right side. And they can have same begin and multiple ends, or vice versa. We know now how to document your features with embedded annotations in your software project. Now we want to use this information. For this, we developed the tool FAXE, which is a short form for Feature Annotation Extraction Engine, and is conformed to our proposed unified embedded annotation specification, and fulfills the main tasks to browse features in your software assets, provide the feature locations, and with the provided metrics to keep the non-technical overview. There whereby it provides warnings when a specification is violated or there is any inconsistency. With this, it can serve for dashboards and other applications as discussed before. The tool is based on a parser using a context-free grammar, which we use because of higher robustness compared to regular expressions. And with this context-free grammar, it is easier to cover recursive appearing keywords. We would like to give you a small summary how the tool works. For this, we have this example source code with a line annotation surrounded by a fragment annotation, which is again an inner fragment annotation, and shown on the command line, which has the same interfaces like the API. We get the embedded annotations for this specific file, and in the printout we can see our free annotations from the source code example above. When we're interested in, for example, the feature donate coins, we can also ask for a specific printout of the feature name and see now only in the print this specific feature. To get for donate coins a broader perspective, we can use the calculate metric command and search now in the whole project folder for this feature. This shows us that this feature has a scattering degree 13, which means at 13 places in the project this feature is used. With this, I want to conclude my presentation where we presented the notion of embedded annotations, some use cases where they can apply, as well as a unified specification and tool support to work with embedded annotations. Thank you for your attention.